With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is the order of reactivity of carbonyl compounds for nucleophilic addition is, and here four options are given to us, and we need to tell that the order of reactivity of the carbonyl compounds for nucleophilic addition. Alright, so first of all we should know what do we understand by nucleophilic addition. See, here we have a compound. Let's say I'll take the formaldehyde, which is also given in the options, as you can see here. Right, so formaldehyde, when we treat it with, when we do the nucleophilic addition of this compound, that is, let's say I'm taking HCN, and in this we know that Cn minus is the nucleophile. So what it will do, it will attack, since this is nucleophile, and nucleophile means it is nucleus loving species, that means it is rich in electrons, and it needs something which is electron deficient, that means an electrophile, right? And here we know that this carbonyl carbon, here the oxygen is what? Electronegative. It will pull electron towards itself, that's why it will have what? A partial negative charge. And this carbon, because oxygen is pulling electrons more towards itself, that's why it is that's why carbon will have a partial positive charge. So thus nucleophile needs what? It needs an electrophile. So here there is the electrophilic center, electrophilic carbon is there, so this nucleophile will go and attack on this, and this double bond will shift towards oxygen, and what O minus will take the hydrogen. So what we will get? We will get this OH, hydrogen, and Cn will come and attach here, right? So this is how nucleophilic addition is going to take place in every molecule with that is given in the option: Ar2CO, R2CO, ArCHO, RCHO, and H2CO. Okay, so now if we see the order, so here if I take if I see the first option, if you see Ar2CO, so for Ar2CO, let's take an example for this compound. Let's say both the aryl groups are C6H5. So here if you see, we have this kind of a structure, C double bond O, and here C6H5, that is your benzene ring, of course. Let me draw the benzene ring here. Okay, they both are the same, this and this is same. Okay, C6H5. Then the next is what? R2CO. Let's take its example as acetone. So here you will be having CH3, C double bond O, CH3, right? ArCHO, let's take the example of benzaldehyde, where your Ar group is C6H5 and this is CHO. Okay, RCHO, let's take the example of acetaldehyde, CH3CHO. Right, and then your H2CO, that is your formaldehyde. So that is H, C double bond O, H. Okay, now as I said earlier, the more the electrophilic center it will be, the more electrophilic carbon it will be, the faster will be the nucleophilic addition reaction. Alright, because if it is having more positive charge toward itself, that means it is a better electrophile, then the nucleophile will be able to react, then the nucleophile will be able to attack on it with a faster rate. Alright, and thus the nucleophilic addition reaction occurs quickly. Alright, the rate will be high, and thus the reactivity will be high. Alright, so here these are the options given to us, and I have taken the example for each of the compound that is given here. So if you see, as I said, that we need that this carbonyl carbon should be more electrophilic. Alright, the one carbonyl carbon which is most electrophilic, that will have the highest reactivity towards nucleophilic addition reaction. Alright, so if you see here, the first one, HCO, first let's see this HC double bond OH. Okay, as this carbonyl carbon has hydrogens both the sides. Let's assume this is first, this is second, this is third, this is 4, and this is 5. Okay, so here this carbonyl carbon is electrophilic, is highly electrophilic. Why? Because it has both the sides, it has hydrogen. These hydrogens will not be applying any effect like inductive effect, resonance effect, mesomeric effect, or any other effect. They will not be applying. It's just a carbonyl carbon. Alright, and oxygen is pulling electrons, and thus it is electrophilic. Alright, now come to this one. If you see here, we have two benzene rings. Here also and here also. This is also a benzene ring, okay? It's C6H5. So here, if you see here, two benzene groups are there, and we know that if I again draw the structure like this, C double bond O and C double bond O. This is the same compound, right? So what will happen here, as you can see, this benzene's this double bond of the ring can go in resonance with the carbonyl carbon, and thus lead to the formation of a resonating structures like this. Positive will come here, double bond, carbon, O minus, and here the ring. And this will be getting, and similarly, this ring will also be able to give electrons like this to it, to the carbonyl carbon, and thus decreasing, because here benzene ring is actually giving electrons to the carbonyl carbon, and thus thereby decreasing its electrophilic character. Alright, and because both of them are giving both the rings are giving electrons to the carbonyl carbon and thereby decreasing the electrophilicity of this carbonyl carbon. Okay, so it will be very less electrophilic. Okay, this carbon will be very less electrophilic, and because this will be the least electrophilic among all these compounds, that's why this will have the least order of reactivity. Alright, this will have the this will have a very slow nucleophilic addition reaction. Okay, because the rate will be slow, and of course nucleophilic addition rate will the reactivity will be very low, because the carbon is not at all electrophilic anymore, because it is getting electrons from the ring. Right, now let's see other options also, and then we'll write the final order. Okay, so let's assume that this for now, before seeing these options, let's take this one as the last one. So your first is the least electrophilic. Okay, if we get more, we'll write it down. Okay, now see here we have acetone, that is R2CO kind of a structure. Here, as you can see, CH3. Here CH3 is giving electrons to the carbonyl carbon. Here this is also giving electrons to the carbonyl carbon, right? Via what? Via plus I effect, that is inductive effect. Both of them are giving, and thereby decreasing its electrophilic character. But the electrophilic character of this carbon in comparison to this will be high. Why? Because here resonance is taking place and here inductive effect is taking place, right? So that's why this will be more electrophilic in comparison to this, but still it is less electrophilic. Alright, so thus this will be, let's say, as I said, this will be more electrophilic in comparison to this. So let's write here like this, 2, 1. So let's see next one. Next is our benzaldehyde. So again, benzaldehyde can also be written like this. C double bond OH. Right, this is a benzaldehyde. Again, this can also donate electrons, just like resonance was happening in this structure. Similarly, it can happen here like this, right? And thus we will get what? We will get a resonating structure like this. A positive charge here. Double bond, single bond, double bond, C, O minus and H. Right. So again, the electrophilicity, because benzene is giving electrons via resonance to the carbonyl carbon and thereby decreasing the electrophilic character. Okay. But if you compare this one and this, if you compare this acetone ones and this one, this will be more this one will be more electrophilic. Why? Although here resonance is taking place and here plus I effect is happening, but what is also happening here in this bulkiness is also there, right? That means a nucleophile, let's say, if it comes and tries to attack on it, it has to face the bulkiness of the 2 methyl groups. Okay, but here it has to face only the bulkiness of only one ring. Okay, that means ring is only one side, right? But here methyl group is present on both the sides, left as well, right as well. Okay, so this bulkiness could be a reason that this carbon is less electrophilic than this. Okay, this carbon is less electrophilic than this carbon, benzaldehyde's carbon. Okay, and this will have high electrophilic character in comparison to this, because here only one ring is giving electrons to it. But here 2 methyl groups are giving electrons. Here this one is also giving electrons, this one is also giving electrons. So it is getting more electrons in comparison to this. So that's why this one has less electrophilic this one has less electrophilic character than this. So thus your order will be like this. It will be like this, 1 and 2, and your 3, that is ArCHO, that means this benzene and CHO, benzaldehyde, it will come before this. That means 3, this one will be more electrophilic than this and this. Okay? So I hope this is understood. Now let's go to the next one. Next one is this benzaldehyde. I mean acetaldehyde, sorry. This is acetaldehyde, not benzaldehyde. So here if you see, again CH3 is present. It is giving electrons via what? Via plus I effect. But only one CH3 is there. Alright, only one CH3 is there. And in comparison to 1 plus I and 1 plus R is going to win definitely. Why? Because of course resonance is a strong effect. Here 2 plus I was applying. That's why it was getting more electron density, and of course bulkiness was also the reason. But here only one methyl group is applying plus I, but here resonance is there. So that's why this will be less this carbon becomes less electrophilic than this carbon. So thus it will be more electrophilic. So we will write like this, 3 and 4. Okay. Now this one, last, that is formaldehyde, HC double bond OH. Here, as I said earlier, it has no plus I effect, no resonance effect. Thus, the carbons, this carbon is not getting electrons from anywhere. Only oxygen is pulling electrons away from it. Alright, so thus this carbon will be the most electrophilic carbon, and thus the order of reactivity of carbonyl of this compound for nucleophilic addition will be the highest. Alright, so thus it will be like this. 5 will come the first. So the most reactive is our formaldehyde, that is HCHO. If you find it out in the structure, the most reactive HCHO, it is only there in the 2 options, that is B and C. Okay, then you have what? 4. And what is 4? Your acetaldehyde, that is an example of what? RCHO. So if you see, only one option has this one, RCHO. Okay, now let's match the rest as well. Third one, after this, third is benzaldehyde, that is ArCHO. So this is also ArCHO. This is correct. Then after this, we have second. Second is, what is second? Second is this, acetone, R2CO. So after that, R2CO is there. That's also correct. And first, that is your AR2CO. So that is also correct. That is at the end. So thus your option C is the correct answer. I hope you understood. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.